When a grinding wheel fails, the consequences can be serious. Burnt parts, fractured tools, or worse. That's why it's not enough to inspect the outside of a grinding wheel. You need to know what's going on inside. At Grindosonic, we build impulse testing devices that reveal that internal quality clearly, quickly, and with just a tap. This method started with grinding wheels for a reason. In high-speed grinding, stiffness controls how the wheel cuts, how it wears, and how safely it performs. If the disc is too soft, it flexes and loses cutting efficiency, causing friction and heat to build up. If it's too hard, it may glaze and start rubbing instead of grinding, which can also lead to overheating or even chipping. But when stiffness is right, you get precision, safety, and long tool life. The challenge was always the same. How do you measure stiffness without breaking the disc? Before Grindosonic impulse technology, factories had two main options. Some ran destructive tests on a few samples, then guessed the rest were fine. Others relied on tapping and listening for the ring. That method is still used in some places, but it's based on human judgment, not hard data. Neither approach tells you what's really happening inside the wheel you're about to use. Grindosonic impulse technology solves that. Here's how it works. We measure the wheel's mass and diameter. Then we tap it. That small impulse sends a wave of motion through the disc. Sensors record the vibration, and the system calculates the stiffness, its elastic modulus, based on how fast and cleanly it resonates. The way the part vibrates tells you how its structure responds to motion. Cracks, porosity, or weak bonding distort that signal. A clean, stable frequency means the material is solid and reliable. You don't need to cut the part or break it or guess based on samples. You test the actual wheel going into service, and you get real, repeatable insight within seconds. That's why Grindosonic impulse technology began with grinding wheels. They demand safety, they require consistency, and they can't be destructively tested. Today, this method is used across aerospace, additive manufacturing, and structural components. But it all started here, with one disc, one tap, and one simple goal. Let the part speak for itself. If you want to bring that kind of clarity into your workflow, contact Grindosonic today. We'll help you hear what your material is really telling you. Grindosonic impulse technology is protected by 13 patents, with additional patents pending.